Example 6, graph the curve with parametric equations. We have x of t, which is equal to t squared plus t plus 1, and y of t, which is equal to 3t to the fourth minus 8t cubed minus 18t squared plus 25. We want to be able to graph the curve of the parametric equations. So I went ahead and did that on Desmos. Okay, before we do that, okay, it says here that the graph below shows the curve in the viewing rectangle between 0 and 4 and negative 20 and 60. Okay, so if we zoom in just a little bit more, okay, towards the point P, okay, where the curve intersects itself, we estimate that the coordinates of P are 1.5 and 22.25. Okay, and then we estimate that the highest point, okay, in a loop has the coordinates of 125, and the lowest point is 118, and we can see that the leftmost point is 0.75, 21.7. Now, let me show you just real quick how you would graph this on Desmos. Okay, and just to review what we've done in the past, okay, you're going to put in the x coordinate as the x function of t, and then the y coordinate as the y function, and then you can put in your values of t, and I used from negative 10 to 10, which gave us that function. So back in chapter 3, section 4.7, we had the following. Okay, we would have to find dy over dx, which when we talked about parametric equations, we want to find dy with respect to t divided by dx with respect to t. So that means in the numerator, we have to take the derivative of the y function. So if we take the derivative of the y function, that's going to be 12 up here. 3t to the fourth is 12t cubed minus 24t squared minus 36t. And then we're going to divide that by the derivative of the x function. So that's going to be 2t plus 1. Okay, so now we need to figure out, where does the vertical tangent occur? Well, that occurs when we set the denominator 2t plus 1 equal to 0. So that means that we're taking dx of dt, which is 2t plus 1, and we're going to set that equal to 0. So 2t plus 1 is equal to 0. If we solve for t, then t is going to equal negative 1/2. Okay, so now what we're going to do is we're going to plug in t equals negative 1/2 into the function of x of t. So it's going to be x of negative 1/2, which is going to equal if we look up here at that function, it's going to equal negative 1/2 squared plus negative 1/2 plus 1. And what that gives us is 0.75. Okay? So what that tells us is the fact that at t at negative 1/2, we get the x parameter to be 0.75. Okay, and then we're going to do the same thing. We're going to plug it into the y. So we have t, which is equal to negative 1/2, and we're plugging that into y to the negative 1/2. And so we have 3t to the fourth, so that's 3 times negative 1/2 to the fourth power minus 8 times negative 1/2 to the third power minus 18 to the negative 1/2 squared plus 25. And so therefore that gives us 21.6875. Okay, so this tells us what is the exact coordinates of the leftmost point. So that means that the coordinates of the leftmost point are the following. So it's x of negative 1/2, comma, y of negative 1/2. And so what we got was 0.75 and 21.6875. Okay, so if we take a look here, we will notice that the leftmost point was located there. Okay. Also, so we found here what dx of dt is equal to 0. Now we got to do the numerator as well. So what happens when we set the numerator dy of dt equal to 0? So we have 12t cubed minus 24t squared minus 36t and set that equal to 0. If we factor out a 12t, then what's left is t squared minus 2t minus 3, which is equal to 0. So we have 12t times t plus 1 times t minus 3, which is equal to 0. So if we solve for x, then we get t, which is equal to 0, t is equal to negative 1, and then t, which is equal to positive 3. Okay, now we're going to do the same thing. We're going to plug in t is equal to 0, negative 1, and 3 into the parametric equations. So I went ahead and did that. So what we did is when we plugged in t is equal to negative 1, x of negative 1 gave us 1, y of negative 1 gave us 18. When t was equal to 0, x of 0 was equal to 1, y of 0 was equal to 25. When t was equal to 3, x of 3 was equal to 13, and y of 3 was equal to negative 110. So we determined that the horizontal tangents occur when t is equal to 0, negative 1, and 3, and the bottom of the loop is going to correspond to when t is equal to negative 1. And indeed, its coordinates are 1 and then 18. So let's take a look up here. There is 1 and then there's 18. So we can see that t is equal to negative 1 gives us the coordinates of 1 and then 18. Okay, so there. Now, similarly, the coordinates at the top of the loop are exactly what we estimated at when x is 0 and y is 0. So remember, at the top of the loop, we got 1 and then 25. So when t was equal to 0, we got the x coordinate of 1, the y coordinate was 25. So the top of the loop was estimated there. But what about the parameter value of t is equal to 3? Well, the corresponding point on the curve has coordinates x of 3, which is 13, and y of 3, which is negative 110. But this graph shows the graph of the curve in the viewing rectangle from 0 to 25 and negative 120 to 80. This shows the point 13, negative 110 is the lowest point on the curve, and we can now be confident that there are no hidden maximum or minimum points. So let's go ahead and do that. So on our graph, we're going to now go from 0 for the x to 25. Okay, and we're going to go from negative 120 to 80. And then let's go ahead and put in that point. So we had our x coordinate, or it's going to be 13, comma, negative 110. And let's label that so we can see it's down here. So yes, we did not see it in the first part of the graph, but it confirms the fact that this is the lowest point on that graph. And so therefore, we can see that the lowest point here on that viewing rectangle is at 13, negative 110.